Good evening, ladies and gentlemen. Imagine getting old. I mean, we're all going to get there, you know. You probably sat on that table just there. You're probably thinking about it right now, you know. You're probably not on a day over 10, you know, but you're probably already thinking about it, you know. And the thing about it, when we get old, one of the main things that can really be an issue is falling over. And the thing is that if you do fall over when you're old, it really leads to a decline in your quality of life. It can lead to hospitalization. It can lead to a lot of long-term injuries that really cause a sort of decline in your, health overall, because that's a very important part of living. And I just want to think about, as a thought experiment, think about this elderly gentleman. His name's James. He's very sporty, he swims, he's very mobile, he's quite happy, he moves around, no problems. But the thing is he's going to have a life-changing injury from falling over. And this injury is just entirely preventable. And I think if we could have had a better way of realizing when he was at risk, better way of working those kind of things out, things would have been all right. He would have had a much healthier time. And why do I know so much about this man called James? It's because he's my granddad, and I looked after him for 5 years, and he had a life-changing injury due to having a fall. And he broke his back, and it would have definitely been preventable had we had a bit more information about whether or not he was at risk of falling over. I'm sure people who care for people are aware of things like this. And this is the part of the presentation where I tell you that technology is the solution. You know, we're going to put cameras up in his home, and he's going to have AI telling us when he's, wobbling over and all of that kind of thing. But the thing is my granddad, he really hated technology. He really wasn't about it at all. And I'm sure anyone who's got an I'm sure most people here know someone who's elderly. They're not so into the technology. Certainly he wasn't. I mean, he got given a computer in the early 2000s, believe it or not, that had a flight simulator on it, and he gave it away. Gave it away to somebody else. Wasn't me. I didn't get to play Flight Simulator. I was absolutely devastated, I've got to be honest. But the thing is people don't want to have this kind of thing in their home. They don't want to have cameras everywhere, all that kind of stuff. But what if I told you that there was already a solution to this problem that already exists in everyone's home? Something that every single person in this room, I'm pretty sure, either knows somebody who does have or has in their home. Everyone does have in their home, in fact. It's something that can sense movement, sense gestures. It's microwaves. Microwaves. Everyone has microwaves in their home. And I'm sure you're wondering, why am I talking about microwaves? And you may have noticed that I'm trying to lead you on to thinking about microwave ovens, right? And this actually comes with a real point, because my research is in microwave waves. But anytime I tell people that I work in microwaves, they just immediately think that I'm talking about microwave ovens for some reason. Like, I was appointed to work at the European Microwave Week, and it took me genuinely over about a week to realize that every single person I told about this thought I was working at some kind of industrial conference for microwave ovens. Anyway, so microwaves aren't microwave ovens. They're actually part of the electromagnetic spectrum. Any device that communicates wirelessly emits these waves, right? And the thing about it is that we, even in my granddad's home, there were at least 3 or 4 devices that emit microwaves. His smoke alarm, his smart meter, his thermostat, all of these devices communicate wirelessly, and therefore they all emit microwaves. And this is the thing that we can use to sense things in the environment. And what I'm going to do now is I'm going to try and demonstrate some of the ways that we can sense using wireless signals with a piece of string. So I'm going to need a volunteer from the audience. Does anyone want to volunteer? I think we've got a very keen volunteer over here. Now, what I need... This is quite long. I think I was initially planning on doing it across the whole room, but it's not really going to work like that. So what I want you to do is hold this string as tight as you can. Okay, what's your name?
Jan.
Jan. Oh, well, that's easy. James, Jan. Right, hold it. Hold the string as tight as you can. Just wherever you want. You're all good. There we go. Right. Okay, so what I want you to imagine is that This is a wireless microwave. And I'm the transmitter, you're the receiver, right? And we're going to be transmitting waves between each other, okay? And the thing is there's different types of things with a wave. The wave has a speed at which it moves, so that's the frequency, right? That's how fast it goes up and down, right? How high it goes, that's the amplitude, so that's how high the wave goes. And that can be changed, how long it takes to get to the receiver from the transmitter. That's a thing called phase, and it's kind of similar to time, is probably the best way to think of it. And then there's the range, so that's how long this piece of string is. And we can have different ranges, and as well, different frequencies. So the different frequencies, so this is one frequency, and then this is another frequency that's a bit faster. And the thing about it is that we can actually have hundreds of these different strings, essentially. And that is the thing that really enables us to be able to do this kind of sensing. And Janet, unfortunately, that is it for you. So thank you very much. You can take the string with you if you want. Do you want it? Thank you very much, Jan. Thank you for coming up. I hope that helped. I've not got much time, so I'm going to have to go quick. Right, so how can we use these to see? We've got all these different waves. We've got these signals. The thing is, though, is that they're actually incredibly complicated. And as a sort of experiment, I've got on the tables, there's a blue little puzzle that you should be able to see. This is some of the data that I deal with in my PhD. And the thing is that if you try to put those things together, you would probably struggle quite a lot to work out what it looks like. But as per usual these days, I'm going to be lazy because I'm a student in 2025. So I'm going to use AI to do all my work for me. Of course. So how on earth can AI help us do this? So it's very good at picking through patterns. It's very good at picking up on patterns in data if you give it enough data. So the idea is that we're going to take lots of training data, and then we can use classification, machine learning, to be able to put together the different classifications. Now, some people here may have worked out how this is going to work. So if you haven't already turned it over, the idea here is that there's a way that we can take these signals and we can make them more easy to pick patterns out of. And that's a process called feature engineering, which is a thing where we might take averages, we might take rates of change, we might take all sorts of different tests that we can, mathematical operations we can perform on the data that we take, and that gives us a much easier to classify signal. And that's kind of part of the method that we use to take better data, if that makes sense. You've already turned over the puzzle, or maybe you haven't. Maybe you haven't yet. Well, you're welcome to turn over the puzzle. People might have already been able to solve it because they're very intelligent, and I salute you for doing that. It's ruined my the thing, but it's fine. So yeah, what about the puzzle solving itself? I don't know if you've read the title. There's a thing about puzzle solving themselves. This is another part of. We've now got lots of different types of data. We have different frequencies. We have different amplitudes, different phases on different frequencies. We've got different feature patterns that we can extract out of it. And what we're going to then do is we're going to fire lots and lots and lots of, we've got all our different data. We can work out which different combinations of data based on just literally just trying lots and lots and lots and lots of different things. We've got the solution, which is this wireless this wave is, this signal that I've captured corresponds to whatever we're trying to classify for. Say, for example, a strange gait, a poor movement, or something, someone, like an old person who isn't moving correctly. And what we can do is we can train a machine learning algorithm to work out which parts of the signal are the correct one, if that makes sense. Which part of the signals correspond, like what the best way that they can correspond to, based on just literally just being like, we've got the solution, and just try whatever you can to get closer and closer and closer to that solution. And just keep checking. And that's essentially like the idea of a puzzle that can solve itself. So, we've gone through lots of different things there. It's been a bit of a whistle-stop tour. And basically, yeah, we can just let the computers solve our own problems. And the thing is that what we can do with this is use equipment that already exists. We can use what these wireless signals are already out there. This room is full of these kind of signals. And if we can find a way of being able to add more features, add more functionality to these things, we can essentially massively reduce the amount of e-waste. It's something that I haven't even had time to mention here, but it's part of being able to use the equipment that we already have to be able to solve problems that we may be able to solve in a different way. We could put loads of cameras up, but do we need to do that? And I think that's the thing about it, is that we don't need this new equipment. We can prevent e-waste, we can save lives, we can improve people's lives using the equipment that we already have. There are a lot of challenges out there for it, but that is what my PhD and my research is about. And I'd like to dedicate this to my granddad. They're both, unfortunately, I didn't make it clear, sadly died. But I just really wanted to, Jim and Frida Tate, what legends, and thank you very much.